Hey everyone, welcome to the problem. Today we're going to tackle LeetCode206. It's listed as an easy problem. I think there are a few tricks that make it a little harder than easy. Maybe call it easy medium or easy plus plus. I'm not so sure. Uh, Definitely wasn't a pure easy problem for me. So what do we need to do in this problem? Well, we're given a linked list. You can see a visual example here where we have 1 points to 2, 2 points to 3, etc. And we need to reverse that list so that the values stay the same, but the connections between them go in the opposite direction. So here, 5 would be the new start of our linked list, and it would go all the way to 1, and then we would know 1 is the end of the list because it's actually going to point to none value. You can see an example here. 1, 2, 3, 4, 5, output 5, 4, 3, 2, 1. Don't be confused by these square brackets. These are not Python lists. These are singly linked lists defined by this class definition right here. I'm going to cover that class definition and how to work with these list node objects so that it feels really easy for you. One other trick or important point that shows up in this problem is there's a challenge at the end that says, hey, linked lists can be reversed iteratively and recursively. And they kind of throw it on the gauntlet and say, maybe you should try doing both. I'll show you how to do both solutions. I'll actually show you two different iterative solutions, one that's extremely straightforward and one that uses 2 pointers and is a little more efficient. And then I'll also show you a recursive solution. The recursive solution is a little trickier in my mind, but I think it's really great to learn recursive solutions when possible, just so that you stay up to date and practiced with recursive solutions for when you finally get to a problem that really does require it. Okay, we can hop over here to a notebook and I can show you some quick examples about how the list node data structure works, and then I'll go ahead and show you the simplest solution that I know to this problem on how to reverse a linked list. So first, just so we can play with this data structure a little, I can show you how to build a list node object. So typically the variable in these problems will be called head, and it'll be defined behind the scenes like this. The list node data structure will be called. We have to supply a value. If we don't, it defaults to 0, and then a pointer to the next object, and that should be a list node object. Notice I've talked about this in other videos. There's no guardrails here, so you could point this to anything, but you definitely want to point it to another list node object. And also value should be an integer, but again, you're not limited to that here. Anyway, let's go ahead and build a quick head object with 3 values. So we can do 1 for our first value, and then it can point to another list node object with the value 2, and then finally it can point to the last list node object with the value of 3. And then I've written a simple recursive print function so that we can play with our code easier and visualize some of these linked lists. So I'm going to go ahead and print out the values here. What we should see is 1, which points to 2, which points to 3, which points to none. So the console should say 1, 2, 3, none. Okay, cool, and that's what we get. Now I'm going to copy this definition of head below and actually show you what I think of as the simplest way to reverse this list, and it's really just to build another list node inside of a while loop. So what we can do is we can initialize a list node with the value of none, and then we can iterate through head. So we can say while head, and just so you know how we're going to iterate through head, the way to work through these list node objects is to assign head equal to head.next. That will pull us all the way through until we hit the value of none, and then we'll exit the loop. And then really there's just one more line of code here that actually involves logic, and that is how we're going to build the new list node that is the reversed version of head. And you'll notice that I've initialized previous as none, and that's going to be the first value we reference. So we can reassign previous inside this loop, and it's going to be a list node, and its value is going to be actually the value that we're currently at with head. So the first time we go through this loop, the value would be 1. That used to be the beginning of the list, and now we know that has to be the end. So if we're at the very end of the list, what should 1 point to? Well, it should point to the value none, and I've initialized previous as none above, We could actually delete that line and just hardcode none in here and then reference previous throughout the loop. I think this is a little clearer, so I'm going to leave it the way it is. So we can reference previous here. And then, well, I missed a T there, didn't I? And then just so we can think this through, that's for when we have the value of 1, then head will update to head.next, which is the value 2. And so then what will happen? Well, previous will reference itself and head.value. So head.value is 2, and previous is 1 pointing to none. So then previous would be 2 pointing to 1 pointing to none. And this would work until we get to 3, and the head.next value of 3 is none, and we would exit. And just to make sure we have the right solution here, we can call recursive print on previous and see what we get. And okay, cool. We get what we wanted to get. 3 points to 2, points to 1, points to none. That is the simplest solution that I know of. It has time complexity of big O of n, and it has a space complexity. I think people use n for that. A space complexity also of n. So however long your input linked list is, your output linked list will be that long too. We can actually improve this with an iterative solution, and I'll show you that here in a second, and that's going to use a two-pointers method. All right, so that was the first iterative solution that I wanted to show you, and now let me show you the two-pointer method. We can copy some code from up here. So we do need head and previous, and we are going to return previous like before, but since this is a two-pointer method, we need another pointer here. So we're also going to have a reference called cur, which is going to be a reference to head. And just like before, we need to iterate through an object, and our object will be current. So we can say while cur. And normally, to keep this loop going, we would do something like cur is equal to cur.next. However, we have an issue here, which is that the way this two-pointer method works is we look to the forward pointer and we reassign it to the previous node. That's why we need two of these pointers. And so we're going to have to access current.next twice. In order to do that, we need a temp variable, which I'm going to call temp_next. And that's going to be a copy of our original forward-looking pointer. And then what we can do is we can, now that we have this copy, we can say current.next, so the pointer that pointed forward, so for example in head, 1 points to 2, we can reassign that to previous. So when we start the loop, it'll be none, and so that'll have 1 be at the end of the linked list, because when we hit none, we know we've hit the tail or the end of the linked list. And then once we've done that, we're free to update previous and move it forward and have it be equal to current. And then the only thing to do after that is to keep the loop going, and we can finally now say current is equal to temp_next. I'll put some more code comments here just so it's clear. So current.next, this is reassigning the forward-looking pointer to look backwards. Then this is moving our backwards looking pointer. And then finally, this is just keeping the loop going. And we're going to return previous, just like before. So I can call recursive print on previous, and we should get 3, 2, 1, none. And we do. Okay. So that's going to get us through the two iterative solutions. Before we dig into the recursive problem, there's something that I want to demonstrate that has to do with pointers and references to variables instead of copies of variables. And I've got a bit of code right here to explain that. So you can see I've got head defined as we've defined it many times before. 1 points to 2, points to 3, points to none. And I've got a new variable called test, and it's defined as head.next.next, meaning 3 to n. And if I print head and print test, as you'll see in a second, you'll see that it's 1, 2, 3, none, and 3, none. And then if I make a change to head, so if I change the, one of the last pointers here, it is not going to affect test. And I mean, maybe that's not surprising to you, right? You're like, why would changing head affect test? And so if I print this out, you can see that originally we had 1 through 3, 3 to none, and then I overwrote the value of 3 with 7 here, right? And nothing happened to test. However, what I want to demonstrate and what I think is very important for understanding the recursive problem is that if I change head.next.next.next, not only will I affect head, I'm going to affect test. And I can run this so you believe me. Notice here when we print test the second time, it used to be 3 to none, now it's 3 to 7 to none. And the reason that's happening is because we've defined test in reference to head. We didn't make a copy of head and then assign it to test. So the pointers in head 1 to 2 and 2 to 3 are only referenced in head, but 3 to n, that pointer, is the same pointer in both head and test. And we're going to leverage this in our recursive solution, but it's a little wonky the first time you see it because we're going to be making changes to one variable and then returning those same changes in another variable. Given all that, we can now start our recursive solution. So I'm going to bring in head, just like all of the other problems before. Since we're going to do a recursive solution, we do need a function. We can't just play around with global variables anymore, so I'm going to define a function called reverse list, and it's going to take in something called head. We can worry about types and stuff later. And then what do we want to do? Well, we've got a recursive function, so we're going to need a base case. We're going to need to increment things somehow, to keep our loop going. And then we have our actual call stack logic. So what are we going to do every time we get to the call stack? Well, our base case is pretty simple. We want this function to work all the way through the list. So we would start at 1 and go to 2 and go to 3. Only when we get to 3 do we want to start actually reversing things. So what we can do is we can check to see where we are in the list. If we're not at the end, then our base case really doesn't count. But if we do get to the end, we need to return the value at the very end. So if not head or head.next, or not head.next, then we want to return head. Okay, that handles our base case. How do we want to keep the loop going? Well, this is pretty straightforward. I just said before that we need to work through all the elements of the list. So the way we can do that is we can define a new variable called node, and that is going to be where we actually recursively call this function, but we need to call it on head.next. We've seen the syntax before on our iterative problems where we saw something like current is equal to current.next. And finally, we just need to get to the call stack logic now. We need to talk about and figure out what we want to actually do to reverse these nodes. And the way to do it kind of comes from that hint, all that preamble I just gave you a couple minutes before where we talked about head.next.next.next and all of that. What we can do, so, and to explain this, I'd like to think about this problem where we're at head. Imagine that I've gone all the way through, we've gotten to 3, we've hit this base case right here where head.next is not defined, so we've returned head. So now we have a variable called node, and I can just put in comments right here. So we've got a variable called node that points 3 to none, and then we've got another variable called head, which is 2 to 3 to none. And what we want to do is we want to get this 2 from head back behind the 3. And so that's actually pretty straightforward. We can do that with this kind of funny logic here. We can say head.next.next, so not 3, but none, is going to be equal to head itself. That'll get the 2 behind the 3. Now, in order to make sure that we don't have an infinite loop, we need to define head.next equal to none. And what that's going to do is it's going to allow us to now have that 2 behind the 3. just like I showed you in the example before, this pointer 3 to n is shared in both head, I'm sorry, I should reference this head, in both head and node. So when we change that value 3 to n to 2, that's going to happen both in node and in head. And so now all we have to do is return our node value. And just so we know that we've got everything right here, we can do we need to create a variable called test and test our function. And then we can print out what we get. We should get 321, and we do. Okay, I hope that helps. Happy coding, and I will see you guys next time.